Have you ever stared at a loading spinner that just goes on and on, seemingly forever? You're just trying to log in, or maybe buy something, and you're stuck in this digital limbo. We've all been there. It's frustrating, right? But what's actually happening behind the scenes when that little wheel just keeps spinning? Why can't your computer just know if something went wrong? Well, the truth is a bit more complicated, and it all comes down to a fundamental concept in computing: the timeout. Imagine you're running a massive logistics company. Your whole business is about sending packages from one warehouse to another. You send out a truck with a valuable shipment. Now, how do you know it arrived safely? You wait for the receiving warehouse to send back a delivery confirmation slip. Simple enough. But what if you never get that slip back? What do? Do you wait forever? Of course not. Your business would grind to a halt. This is where the timeout comes in. You set a rule. If I don't get a confirmation slip back within, say, 3 days, I'll assume the truck got lost, crashed, or maybe the confirmation slip itself got lost in the mail. After those 3 days, you declare the shipment timed out, and you send a brand new truck with the same package. This is the retry mechanism. Now, setting that 3-day timer is a tricky balancing act. If you set it too short, say, just 1 day, you might get a lot of false alarms. A truck could just be stuck in a bit of traffic, totally fine. But because you didn't get the confirmation in time, you've already sent out a duplicate shipment. Now you have 2 trucks heading to the same place with the same stuff. That's inefficient and wastes resources. The receiving warehouse gets a duplicate order and has to deal with the confusion. On the other hand, what if you set the timer for too long, like a month? If a truck really did crash on day 1, you'd be waiting an entire month before doing anything about it. Your customer is waiting, your inventory is in limbo, and your whole operation is stuck. The system hangs. This logistics metaphor is almost exactly how computers and networks operate. When your browser sends a request to a website server, like your login information, it's like sending out that truck. It then waits for a confirmation, a receipt, from the server saying, "Yep, got it. You're logged in." But the internet is a wild and unpredictable place. It's not a perfectly smooth superhighway. It's more like a network of thousands of tiny, sometimes unreliable country roads. Packets of data can get lost. A server might be overloaded and slow to respond. A router somewhere in between could hiccup and drop your request. There are a million things that can go wrong. Your browser has no way of knowing for sure what happened. Did the request get lost on the way there? Did the server receive it but crash before it could reply? Or did the server reply but the reply got lost on its way back to you? This is the core uncertainty of distributed systems. From your browser's perspective, a slow response and a lost response look exactly the same. Silence. All it knows is that it sent a request and hasn't heard back yet. So, engineers implement timeouts. Your browser will wait for a certain amount of time, maybe 30 seconds. If it doesn't hear back from the server within that window, it gives up. It assumes the request failed and shows you that dreaded "this site can't be reached" error, or in some cases, it might automatically retry the request behind the scenes. That little spinning wheel is basically your browser's way of saying, "I'm waiting, my timer is ticking, but I haven't heard anything yet." Just like with our logistics company, setting that timeout value is crucial. Too short, and the browser might give up on a perfectly healthy server that was just a little busy, causing unnecessary errors and retries. This can actually make a busy server even more overloaded, as it's now getting duplicate requests. Too long, and you, the user, are left staring at a spinning wheel for minutes on end, wondering if the site is broken, before the browser finally gives up. This leads to a terrible user experience. This concept isn't just for websites, it's everywhere. When your phone says, "sending" on a text message for a while, that's a timeout in action. When a video game disconnects you from a server due to high latency, that's a timeout. It's a fundamental defense mechanism that prevents systems from getting stuck in a state of waiting forever. It's an admission that the world of networks is inherently unreliable, and we need a practical way to deal with that uncertainty. When a timeout happens, the system has to make a judgment call. It has to decide, okay, I've waited long enough. It's more likely that this failed than it is that it's just slow. But it's always a guess, an educated one, but a guess nonetheless. Because of this uncertainty, a timeout doesn't necessarily mean the original request failed. Remember our second truck? The first truck might still arrive eventually. This can lead to some strange behaviors. Have you ever clicked the buy button, got an error, clicked it again, and then discovered you were charged twice? That's a classic example of a timeout and retry gone wrong. Your first request probably did reach the server and process the payment, but the confirmation got lost on its way back to you. Your browser timed out, assumed it failed, and when you clicked again, it sent a completely new purchase request. The system wasn't designed smartly enough to recognize that the second request was a duplicate of one that had already been processed. So the next time you're stuck looking at an endless spinner, you'll know what's going on. It's not just a dumb loading animation. It's the visible part of a deep and complex system of timers, retries, and educated guesses, all designed to navigate the fundamentally uncertain and unreliable world of computer networks. It's a constant battle between waiting too long and not waiting long enough. Now, all this talk about requests and responses brings up another interesting question. Once you successfully log in and the server knows who you are, how does it keep track of you? You click around the site, moving from page to page, and it still remembers that you're logged in. You're not sending your password with every single click, so how does the website remember who you are across all those different requests? We'll dive into the world of digital identity and sessions in our next video. Thanks so much for watching. If you found this interesting, give this video a like and consider subscribing for more deep dives into how our digital world really works. See you in the next one.